All right, so today we're going to do equations of lines. Most or all of this should be review for you from things that you did in pre-algebra and algebra 1. But I understand if you have forgotten some of those, so we'll do lots of reminders. The first reminder is this: the y-intercept is the point where a graph crosses the y-axis. It is the value of y when x is 0. That's the part that people tend to forget. They know that on a graph it's where it crosses the y-axis, but they forget that it's the value of y when x is 0. On the other hand, the x-intercept is the point where a graph crosses the x-axis. It's the value of x when y is 0. So x-intercept crosses the x-axis. It's the value of x when y is 0. Okay, all that goes together. So for this class, we'll write all equations of lines in one of two forms. And before I go on, I want to point out to you that in your book on the homework tonight, it will frequently ask you to put your answer in a particular form. Ignore that. Put it in whatever form makes most sense for the problem. Okay? So it may say put it in slope intercept, and you're like, oh, but point slope is so much easier. Put it in point slope form then. Okay? Just ignore that part of the instructions tonight, please. So slope intercept form is the one that you have known the longest. You learned this probably in pre-algebra. If a line has a y-intercept b and a slope m, then an equation for the line is y equals mx plus b. You're used to that one. I have some students that like to write it y equals b plus mx. Okay, I don't care. It's just as good. Yeah, I know, it makes people turn up their nose. They're like, that's weird. But in some ways it kind of makes sense, because the y-intercept is a y value. And isn't it where you start when you're graphing? Don't you graph the y-intercept first? So in some ways, to me at least, it makes a lot more sense to do it as b plus mx, because then that's where you start, and then that's where you go from there. It's entirely up to you. I don't care. I'll write them in y equals mx plus b because that's what you have had pounded into your head for at least a year, okay? The other one that we'll do is point slope form. And there's a couple of different ways point slope form gets written. Just to be consistent, I'm always going to write it in this form. This says, if a line contains a point with coordinates x1, y1, and has slope m, then the equation an equation for the line is y minus y1 is equal to m times x minus x1. You may have seen something slightly different last year in algebra. This is pretty much what people use as you go forward. If you don't know that one, you need to memorize this one. This one is actually, although in Algebra 1 and in pre-algebra, they almost exclusively do y equals mx plus b. Yeah, when you get to big boy math, nobody uses it. Well, I don't want to say that. That's too strong. In calculus, the number of times we use that form compared to the other, it's probably on an order of 10 to 1. We use point slope all the time. We almost never use slope intercept. Okay? All right. So, part of what you're going to have to do is decide which of those two we're going to use. And the answer is really easy. If you have a point and a slope, use the point slope equation. That's it. Okay? If you don't have a point and a slope, then you can use the other one. But if you have a point and a slope, use the point slope equation. It will always work. All right, so for this one, write an equation of the line with y-intercept -8 and a slope of 3. Well, I've got the y-intercept and I've got the slope. So that's slope intercept. Y equals mx plus b. So the slope is 3, and the y-intercept is -8. So plus -8 means just -8. Same thing. That's it. Now, can you do this one in point slope form? You absolutely can. In fact, you can do every single problem that we have for writing equations in point slope form. Because if the y-intercept is -8, that means that the point that it goes through, the x-coordinate is 0. Remember, the y-intercept is the value of y when x is 0. So that's going to be 0, -8. With a slope of 3. So if you don't know the point slope equation, I suggest that you write it down every time you use it until you have it memorized. So this is going to be y minus -8 equals, the slope is 3, x minus 0. What is y minus -8 the same thing as? Y plus 8 equals, what is x minus 0? If I have x and I subtract nothing from it, what do I have? You still have x. So this is 3x. Sorry, I put 3. Thank you. So it'd be y plus 8 is equal to 3x. Is that the same equation? Yeah. Is it in a slightly different form? Yeah. Does it matter? No. God bless you. I will happily take this as a perfectly good answer. All right, let's go on to the back. For this one, write an equation for the line with slope 4 through the point with coordinates -7, 2. They gave me a slope and they gave me a point. Use point, exactly right, use point slope. So y minus y1 is equal to m times x minus x1. So I've got y minus, what's the y coordinate? 2. Equals m. M stands for the? No. Right. You're thinking about that other geometry. Yes, measure of the angle. But here, m stands for the slope, which is 4 times x minus -7. The only thing you have to do to this is a little cleanup. Because what's x minus -7 the same thing as? X plus 7. That's it. No, because it says write an equation, not solve for x. Okay? Yeah, you get so used to solving for x that you feel like you need to do something with it, and there's nothing else to do here. Okay? No, I totally get that feeling where you're like, I feel like I should be doing more. No, you just write the equation. All right, this one asks you to change this to slope-intercept form. Can you change it into slope-intercept form? Yeah. The way that you change it is this. I'm going to rewrite it over here. We distribute the 4. So that'd be y minus 2 is equal to 4x plus 28. Add 2 to both sides. And that'd be y is equal to 4x plus 30. Now, before we go on to the next problem, this is part of the reason why point slope is, in almost every case, better than slope intercept, because let's say I asked you to graph this. If you're graphing this, you have to have an enormous graph, don't you? Because the y-intercept is way up there at 30. Whereas if you graph this one, well, you just need to go to -7 on the left. You don't have to go to 30 something. It's a lot easier. Okay? Now, occasionally, it won't be as straightforward. Take this one. Write an equation for the line through the point 0, -6 and 4, -14 in point slope form. They didn't really have to tell you the point slope form. What are we missing here? The slope. But didn't we just do an assignment the last couple of nights where we found the slope? Yeah. So the slope is equal to, I'll do -6 minus -14 over, since I used the -6 first on the top, I have to use the 0 first on the bottom. That's 0 minus 4. Remember, this becomes plus a positive. -6 plus 14, they're opposite signs, so we subtract and keep the sign of the larger numeral. 14 minus 6 is 8. There's more positive than negative, so that's 8. And 0 minus 4 is -4. For equations, I usually just write it as a whole number. Now, do we have a point and a slope? We actually have 2 points and a slope, and you can pick either one of them. Your choice. So y minus y1 is equal to m times x minus x1. Let's use this point. So that would be y minus -14 is equal to -2 times x minus 4. So it's y plus 14 is -2 times x minus 4. And you just leave it like that. That's perfectly good. All right, let's do one more of these, and then we're going to turn it around and we're going to graph from the equation. So here, write an equation with x-intercept -3 and y-intercept 5 in point slope form. Well, it feels like they didn't give you a slope or a point, doesn't it? But they actually did. They've given you actually 2 points, but they haven't given you the slope. Remember, when the x-intercept is -3, that means it goes to the point -3, 0. Because that's the x-intercept, this goes in the x's place. And if the y-intercept is 5, what point does that go through? 0, 5. Now we can find the slope. So 0 minus 5 over -3 minus 0. It's -5 over -3, and a negative divided by another negative gives you a positive. This is 5/3. And now you have lots of choices for how you want to write your equation. You've got a slope and a y-intercept, you could use the slope-intercept. You've got the slope and 2 points, you could write 2 different ones depending on which point you pick. It doesn't matter. So let's say you wanted to do slope-intercept. That's y equals mx plus b. So that'd be y is equal to 5/3 x. And what's the y-intercept? 5.
Oh, 5.
5/3 is the slope. And you can leave it like that. It's a perfectly good equation. You could put it in point slope. y minus y1 is equal to m times x minus x1. Let's say I picked this point. Okay. That'd be y minus 0 is equal to 5/3 times x minus -3. And then you just do a little cleanup. Y minus nothing is what? It's still y, yeah. You haven't changed it. X minus -3 is the same thing as x plus 3. Or, and I'm being a little ridiculous now, you could use the other point. Be y minus 5, because I'm taking the y coordinate, equals 5/3 times x minus 0. What's x minus 0? X times 5/3 is 5/3 x. All of those are perfectly good, despite what most Algebra 1 textbooks will try and make you think. Those are all perfectly good equations. Okay? All right, let's switch it around and go the other way. These first two, you did a lot of these, or you have done a lot of these. This is in slope-intercept form. So you've got to plot the y-intercept first because you need a point to start from. The y-intercept is +2. The slope is 2/3. So our slope triangle would go up 2 and to the right 3. If you're really near the edge, remember that +2/3 is the same thing as -2 over -3. So we could go down 2 and to the left 3. And I like doing it both directions until I run out of room, because it helps me to draw a line that is at least somewhat straight. By the way, I do not require that you use a ruler to graph your lines. I'm like, it's a sketch. Okay. All right, how about this next one? What form is it in? Slope-intercept form. What's the y-intercept? -1. That's where I start. What is the slope? -4. Be really nice if that was a fraction. -4/1. So from here, my vertical change is -4. And then I move to the right 1. Or I could have gone up 4 and to the left 1. It's the same thing. Okay, basic graphing. You've done that a ton. Started doing that in pre-algebra. Did it some more last year. You've also, I'm sure, done some of these. These are in what form? Point slope. Now, before we actually do that, let's back up for just a second. Let's look at this equation and look at the point. In the equation, next to the x, what do you see? God bless you. -4, right? You see -4, but the point is +4. And right next to the y, what do you see? A +14, but the point is -14. It's always the opposite because of this negative sign in the equation. It's always the opposite. So, when we're ready to graph this, the point that this goes through, what do you see next to the x? +4. So, my point, that coordinate's going to be -4. You okay? Yeah.
Oh, yeah, I'm good.
Okay, if you need to stand up, that's fine. What do we see next to the y? -3. So what is the y coordinate going to be? +3, exactly. So -4, +3. That's my starting point. And then the slope is -2/5. Pardon? Oh, no, that doesn't change. So we're going to go down 2 and to the right 5. And I'll do that a couple of times so that I have plenty of points to try and hit. All right, this is in point slope form. Next to the x, what do we see? -1. So my point, the x coordinate is going to be +1. And next to the y, what do we have? +4. So the y coordinate will be -4. Again, that's because, God bless you, in the point slope equation, there's a minus sign in front of these. It's always going to be the opposite. So this is going to go through the point 1, -4. And what is the slope?
5/2.
Yeah, the slope is 5/2. So we'll move up 5 and to the right 2. So it looks like that. What?
I just found out that my ruler is also an eraser.
No way.
Yeah, actually.
Yeah. What did she say? Tip of it erases.
So like if you needed to erase a whole page, could you just...
Yeah, look. Like, rise over one.
Is it now?
Like the entire blackboard?
Yeah.
Oh, crazy.
That's pretty cool.
Can I see? Oh my goodness.
Uh-oh, yeah. Now the whole class is distracted. All right.
Look what you've done, Lauren. Sorry, guys.
That's pretty cool, though.
That-
Wait, it's a good eraser, too.
It's not one of those janky erasers that just smudges everything.
Yeah.
Oh, yeah, it's like those old erasers and those pencils that you find like in a cabinet or something.
Oh, yeah.
Really
Orange
bad.
erasers.
Oh, yeah, I know the ones you're talking about.
Yeah, they're like stale.
Why are you doing the Macarena? I'm assuming that's what that was.
He was doing the mock
Okay.
I don't know, I saw it the right way.
All right. So last two, sometimes these bug students, but they're really, really, really easy. So y equals -3. Okay, on the y-axis, I'm going to put a point at -3. And then they're like, well, then what do you do? Well, let me ask you a question. This point right here, what's the y-coordinate? This is saying the y-coordinate is always -3 no matter what. So it's just a horizontal line.
What does this bug people? It's like a free.
Like literally.
What?
It's a free point. How does this bug people? I think we should have a lot of these on it. Our entire test should just.
No, literally.
All right, what about this one?
It's up and down, it's
Yeah.
vertical.
And it doesn't change.
You got a 2 on the y-axis.
It's going to cross the x-axis. It's never going to touch the y-axis. And it's all the points where x has a coordinate of 2.
I'm so happy.
You're so happy you decided to brush your hair with the eraser?
No.
All right.